of slides to cover, so I don't know if you have been with a meetup with me recently last in November. I did one. So we have slides, we have something to present. However, I hate this kind of presentation like that, and you just sleep in your corner, and after that it's good, eat pizza and go home. So we did a lot of big day today. It's late, so I want more interactions, meetings, and so in the agenda I have a Q&A, but I hope the Q&A is during the meetup. So hope you will probably learn something today, but I want also you learn also about you, what you think, how you done things, because this is the way to share, this is the way to participate together. So there is no stupid questions, so we are here to learn something. So if there is something completely no sense, just ask. There is no stupid questions, so we are here to learn something. So please stop me and say, "Oh God, I don't understand that," and we can try to explain. This is an agenda in my slides. We are not. If you broke all the agenda today because you're asking a lot of questions, I will be happy, because that means I covered a lot of you questions, and so this is I think this is how I present things, but sometimes it's not relevant because you have probably different way to see things. Make sense? So don't hesitate, stop here, and if you don't understand. So normally we were two to present, and there is someone who left me, so he's in travel to Paris. Anyway, he needed to catch his flight, but so I will be alone. So I said 10 years of Hadoop at +2. So we had celebrated 10 years in Hadoop 2 years ago, and now it's 12 years that Hadoop exists. And we will try to discover what is Hadoop today. Who had a notion of big data? Who already heard about that and have a notion? Yeah. That's starting very well. Thank you, guys. Who is working with big data? Good. Okay. You are working with big data?
Yeah, it doesn't look like it, but I am, yeah.
Okay, so maybe you have not the right definition of big data. We'll start with that.
Okay.
Okay, that's good. So that means there is a lot of disparity in the group, so we need to, what I want to do is to everyone will gain in this meeting, so we will try to do very slowly, and if we want to go fast, we can do also very complicated things. So let's start. So this is the agenda I want to do today, tonight. We talk about big data, we're talking about Hadoop, why Hadoop. We go deeply in Hadoop, what it is, the ecosystem of Hadoop. And after that, we will talk. So I think we will stop the pizza here to make sure that we will eat pizza. And after that, the second part, we talk about NoSQL. Because NoSQL has changed a lot of things in the data side. So we'll talk about that, what it is, what it means. Also some mistakes. I saw again last week in London in the conferences, some people, I will show you some slides. It's not the way to define NoSQL, but we will go there. And after that, the last bit is how we did, so how we build the cluster in Hadoop, and how is the deployment process internally. So how we do that here. That would be also a good way if someone wants to go more deeper in the cluster, in Hadoop cluster. So what is big data then? Good question. What it is? So John, you said you work in big data. So what's the definition of big data?
So
if I knew that you asked me a question, I will never come.
so we're talking like Are we talking like terabytes of data? Would that be defined as big? Terabytes? No? What's bigger than terabyte? I don't know.
Petabytes.
Yeah? Is that big enough?
What do you think, guys? Is it the definition of big data?
Isn't it more the randomness of the data?
Interesting.
Because I read something on big data which was discussing how, I think it was Google did an analysis of searches for flu, and they were able to identify epidemics before they actually occurred.
Yeah.
So that's more randomised data really, rather than we've got petabytes worth of metadata. It's more randomised. I don't know whether that's true or not. So.
Interesting. So who is the first company who fall in the big data sphere? I would say big data problem. So it's not a bad problem. It's good to have. But who is the first company who fall down?
Would it be Google?
Yeah. I'd probably say Yahoo or Google.
Yeah.
It's the same. Yeah, Yahoo was the first before Google. Anyway, so Yahoo and Google worked on this problem the first. What they have is, okay, talk about the volume, so collect all the data in the internet, so it's huge. Even 10 years ago it was quite huge. So we define what is the volume. But it's not that the problem. So if you look at Google right now, what they're able to do is not just the volume the problem. So they want to do a search. So the search needs, there's two things. There is getting all the volume of the internet, yes, but you need to be fast. So we don't want when you do a query, waiting, oh, I need to go to coffee now because Google is running. We get the spinner. And another thing very interesting is more for people who are working on data. This is more about the problematic that Google have in the beginning. And the data is not about randomness, it's about the structure. It's not structured. So the picture is not structured. The video is not structured. The voice is not structured. A crap Word document, I said crap because we can structure a little bit the Word document, but the text is not structured. So how we can collect this data which is not structured, that means we can't easily create a database and put that in there with a nice structure and have that make a search on this. No, that's not possible. That's called the problematic of the big data. It's not just the volume, it's also the velocity, it's also the variety of the data. That's caused the problem. So I will start again for Google because Google is the very good example of company who did that and who fall in the problem and get with the solution. And the solution we talk about is Hadoop. This is how they did it. So anyway, let's finish my presentation. All the thing is here, so we go more deeper in there. So big data. So this is a Deloitte slide about what is the size of the data, what we are bracing the data. So if you are talking about data in the internet, in the digital world, in 2013 we have 4.4 zettabytes, and they projected that in 2020 we have 44 zettabytes. So we are not anymore at terabytes.
So how much bigger is a zettabyte than a terabyte?
That's a good question. We get there.
Okay.
So the data useful to be analyzed is 22% only of 2013, and it will increase of 37%. The data in mobile and people is 17%, and it will increase because we are more and more using the smartphone, 27%. And all the IoT device, we only have 2% of the data in 2013, and it's increased to 10%. What is very interesting, this slide from Deloitte is this. You see that 90% of the 90% of the data is unstructured. And in most of a company, we are only thinking about the data on the database, or structured, and we just forget all the data that is not structured, because they have some values. And it's huge. So, first question, want to learn something today? Great. So everyone has a USB key. Yeah? No? No one? Is out to date? Is
Out of date. That's all.
never. I'm old-fashioned then.
Everything's on the cloud now.
Everything is on the cloud. Okay. If you're on the train, in the Virgin train, you don't have any Wi-Fi, so how will we do it anyway? Okay, let's forget the USB key. Everyone know what is a megabyte? Yeah? That's great. Megabyte? One? Okay. So a megabyte. So a megabyte is how many bytes?
Just over 1,000.
2024.
No, that's kilobyte. It's 10 to the 6, isn't it?
Oh.
So after megabyte, what we've got?
Gigabytes.
Yeah, thank you. Giga. So is
10 to the 9.
yeah. So it's a megabyte. Yeah. Less like that. After gigabyte, we got
So it's
terabytes. Yeah, we are in the big data now. After terabyte.
petabytes.
And after petabyte.
I don't know.
Big data.
We are in zettabyte, do you think?
Is it Zeta? Is that the next one? I don't know. I would have thought so.
So after petabyte we have exabyte, and after exabyte we have zettabyte. So exabyte, zettabyte. So the universe of the internet, we are in exabyte. So internet is processing 1 exabyte every day of data. This is okay, approximation. It's not completely right. Yeah. So what said Deloitte? We are now in the digital world of internet, etc. All the device, what we process data. So all the data in the world, in all universe, is zettabyte. So we are talking about zettabytes. So don't get too much getting there. So most of the company are more in terms of petabyte because we are not processing all the data in the internet, obviously. However, this kind of big data is what is possible is to get at this level. So Google are easily on petabyte, and they get now more in exabyte, and they have no problem. There is something also very interesting is about Google again. Have you seen one time Google falling down?
No.
So that's also one of the key things they try to resolve in terms of the data. Okay, we want to create a service that it's every time available. Every time. It can't go down. So how many times it happens when you have a data and you just get deleted and you don't have any more the data? Or you go to the USB key, or you share folder and someone delete my data, or we don't have it anymore. And they are not managing like in the old school of IT as a backup and etc. They're using backups. If you ask someone in Google, they have no backup. How do you do that? That's something we learned today. Anyway, so that's the big data. Quite a definition. So in our company, we are not talking about exabytes or zettabytes. We are talking about internal data, obviously. So we have, all the companies have this kind of data in terms of transactions, log data, emails. So that's also the data that is not necessarily structured. It could be unstructured. And also sometimes some external data coming in your company. Like for Apache, for instance, it's called the smart measures, smart reads, it's coming, and you have to process them. So big data is not just because people think about big, they think about size. The problem has never been, it's a problem of size, obviously, but at every generation, we have a problem of size. Every time. So when we're talking about gigabyte, for us is easy, but if you go 50 years ago, gigabyte is huge. It was huge. So size, yes, but it's not that. It's more than the size. It's the structures. So I will not going too fast for the NoSQL, but we saw now with the big data area coming, a new generation of database coming also. So remember in 1970, we switched from file system to a database. This was a new concept of coming. We can create a database that is, we will see that after the pizzas. But now with the big data also, we saw a new trend on the database that's called the NoSQL. And that's also something we will look at. So there's something very funny also with the big data. So this is also what's happened in 1 minute in the world of the digital. So in 1 minute we have a lot of things happen. So I don't have the slide for 2018 yet, but like for instance, in one minute, 60 seconds, you can see how many emails has been sent, which is a rough number, how many messages in WhatsApp, how many videos in YouTube has been viewed. So all this number is very huge. And what is very interesting in this chart is more about it's not going to stop. It's increasing. Okay, so I like this definition of Gartner. So Gartner has a great view on how we can define the big data. So as we saw, the big data is high volume, okay? But it's also high velocity. So we want something very quick to be processed. So it's also high variety of information and require a new form of processing to enable instant decision making, insight discovery, and process optimization. So let's get back to Google again. So when they have this idea of, and Yahoo, try to create a search engine on top of the internet, the world of the internet, obviously they look at the solution, what is existing in the market. So why didn't take an Oracle database and put that in there? Or a SQL Server? Everyone have notion of databases? It's clear? No? You have a right to ask questions.
Well, SQL Server and Oracle are more structured data, and you're not wanting structured data.
Yeah. So that's the concept of databases. When we move from the file system in 1970 and we create a new concept of databases everything needs to be structured. Everything. So we need to have tables, when we could put rows, but in every table has to be structured. We have to have definition. So let's take a web page. A web page to another website is not the same. So how we will create a table that fits every type of website? That's complicated. So that's why they create their own system. Yahoo and Google together say, okay, we give up that. We don't want any more databases. It not fit for problem. And they have created their own system. And their own system has a name. And the name is, come on, help me guys. Yay! I'm happy there is someone who's following. Okay, Hadoop. So that's how they do it, and that is still how they did now. Okay, has evolved due to time, but that's fantastic. So, and I will try to go deeper in Hadoop and explain how it works. I don't know if I go now or I'll let later. Okay. So what is Hadoop? So Hadoop is now, if you look at Hadoop now, it has completely changed on how they do things in the beginning, Yahoo and Google. The first thing to know is how, so everyone is aware of the concept of file system? No? No. Okay. Let's imagine file system is in Windows, is where you put your data. Roughly. It's difficult in Windows. So Windows has its file system, and every type of data in the file system, every type of file is split that in 4K. It's small piece of data. He put that physically in his drive. You are too young, but some older people in Windows, for instance, 2000, 2008, etc. You remember you have to defragment the disk. Do you remember that?
Yeah, yeah.
You are too young. You never defragment the disk.
You still have to do it. You still do it.
No, now it's doing automatically. Not very automatically, but you have to plan that, and he's doing it. Anyway, so it's the way to rearrange the file, because physically it's a small piece of data, and to fit the defragmentation, we put your physically file together to make speedness in your thing. So when you open a file in Windows and it's very slow, it's probably your disk is not defragmented. Physically, is a piece of it. So in Hadoop, they said, we are big data, time of volume. We want to store any kind of data variety. So we don't need this file system like in Linux, same thing, 4K. We want to have a file system that is bigger. So Hadoop, the core system, is what we call HDFS. I don't know, it's a whiteboard. You try. Oh, there is something. So the core thing of Hadoop is HDFS. And HDFS stands for Hadoop Data File System. And they had reinvented the file system of Hadoop. So what it means what is doing this file system, because they are processing big data, all the fragments, all the block size in this file system is not anymore 4K. It was 64 meg, now is 128 megabytes. So every type of data is going to Hadoop, is split that in 128 megabytes. Which is quite big, and it keeps this block. This is the block, the minimum block size in Hadoop. The second thing that's happened in Hadoop is what we said previously. We don't want the system failing. We want the system working every time. So there is a new concept in NoSQL, and especially coming from Hadoop, is say, why storing that in one server? Why we don't use small server, not very strong, but multiple server? That's called a cluster. So Hadoop works in cluster. So all this data is stored in different servers, not one. For people who want server now, could be that. So if you want to replace server as a computer, it's the same. Okay, we change the slide now. Okay, so is different servers. But that makes no sense, because the data, if it's storing the data here, if this server is going down, it's the same problem. So what they did, they have what we call a replication factor. So that means we don't store the data once. By default, the replication factor in Hadoop is 3. So the data I will store it here, maybe here, and maybe here. When I said maybe, it's because we don't know. And what's the point to know? And that's why they need a master. So the cluster needs a master who will drive that and say, okay, my data that you've got, I know exactly what it is. It's here, it's here, it's here. And more than that, if the data you've got is a big file, is a big video, or is a big picture, it will split that because the block is 128 megabytes. So if you have 500 megabytes of data, a file, it will split that in 128. 128. After that, you need to help me on the math, please. 128. 128. After that, it needs to rest anyway, X megabytes. So it will have 1, 2, 3, 4, 5 blocks. And these 5 blocks is splitting 3 times somewhere. And this is the master who knows exactly where the data is sitting. For one reason, to avoid this problem of being available every time. If the server is going down, don't care. I've got the copy otherwise.
What happens if the master goes down?
How we got there? So this is single point of failure of Hadoop. Is the master. Did they destroy my slide now? That's great. It's a good question, very good question. So the single point of failure of Hadoop is the master. So there is a lot of techniques about that, duplicate the master, and there is a slide about the distribution of Hadoop. There is MapReduce, who completely remove in the Hadoop distribution the master. And he moved the same concept, moved the master in every node.
Okay.
So there is no real master, everyone is working together. So there is different way to tackle this problem. Very good point. So they did that, and this is how it works, and still how it works. I don't know what is the replication factor in Google. It could be huge, it could be 10, it could be 100. But that's very fantastic. So if you have servers going down, there is no impact. You have the time to fix it, you have the time to think, and after that it's going well. And this is the new, what's a Gartner, the new way to process the data. It's not finished, there is a lot of things to say again. So Hadoop is a distributed data storage and processing platform. So I'm just talking about the storage now. I didn't talk about the processing part. So it handles the low-level data for development. Okay, I will talk about this if you want. So main characteristic is scalability. So this is something very interesting, like in all cluster Hadoop. If we get more and more data, no problem. I can add another step in my cluster, and that's it, and it works. If I need more processing for the more CPUs and more memory for the processing part, I will go after that. Same, I add more cells. And nothing changed. Fault tolerances, so we have to talk about this, and principal data locality. So, principal data locality is the way that the data is still local for the processing. So we talk about the processing, I don't know, now or after. So the thing is, with Hadoop, the data is each node. The nodes is the name of the servers. What is very interesting is that there is nothing about, you can change the function of the nodes and say this node is only for storage and this node is for processing. But what is very great is to have both. So for instance, in our cluster, the server is doing both. What it means? It means when a developer has a question on the data, want to process the data, you ask a question and every service will run on the local data. So that means there is no servers who will process all the data in the cluster and get back to the answer. Everyone will do his part. And after that, there is a collection of data. So this way to work is called the MapReduce. So every server will do their work, and after that, there is the collection of the results. I don't go too far for the, I don't know if I have a slide for the MapReduce. Yeah. So, what we call in Hadoop, the core component in Hadoop is HDFS and MapReduce. So there is Hadoop 1, Hadoop 2, there is the yarn on top of it. So the yarn is more about to manage the processing, because there is not anymore just MapReduce now. There is others, like Spark, and that's why they add yarn to make sure that the resources are working very well. So there could be a conflict in the resource. So yarn has been added in Hadoop 2. So MapReduce, the problem with MapReduce works very well. So is the concept of Hadoop is the core platform, the core function of Hadoop. However, what's the main problem in MapReduce? What could be the main issue? I lost you guys, I think. What could be the main issue for MapReduce? What is the main issue for MapReduce? And that's why now I'll give you the continuity. No one now is using MapReduce anymore.
Because you can't scale.
Yeah. Why can't scale?
Because there's, I don't know if this gets.
Yeah, it can't scale. Why it can't scale? There's no bad answers, guys. Let's try.
What is MapReduce? What's it do?
Okay, let's go back to the cluster. So MapReduce is the processing part of the data. So HDFS is where we store the data.
Yeah.
Okay. So let's imagine you have in your favorite coding like Pig or Java or even SQL now, you want to query the data. So you will ask to the cluster, please give me my answer. The basic example is the word count. You have a big file, a big book, you put that in Hadoop, and you want to count the number of words. Okay. So the data is split in the cluster. Probably 3 times, probably 4 times, probably 5 times, and not necessarily in one piece, as we said in HDFS. It could be in different pieces. So the master knows exactly where is the data. So you're asking the word count. So if in the servers who's storing the data is also a job processor server, it will run the MapReduce. So MapReduce is, it will count the number of words in each data storage locally. So here I will count my number of words. It's not necessarily the whole book, it's a small part of the book. So I will count. So I have 10 who, I have 100 added. It's a nice book. I have 3 big data, etc. And in the other processing, it has another result. So it has, I will start in the beginning. It's not doing that. The map is first is mapping, so it's adding 1 to every word. So 1 for who, 1 for who, 1 for who, etc. It depends on how you will code. 1 for Abed, 1 for Abed. You need not more Abed if it's a good book, and 1 for big data. It will do exactly the same calculation for every piece of data. And after that, there is the function called, this is the map. We map the data on the function. And after that, there is a function of reduce. And reduce is a sum. So it puts everything together, it will sum. So I have from this, I have 10 who. From this one, I have 15 who, so equal 25. And here I have 100 abed, and I have 10 abed, so equal. So this is the reduce part. And this is the map part. And after that, it gets the result.
Okay.
That's MapReduce. What's the problem, major problem on the MapReduce? Man said scalability. Why?
You can two item map reduce another item.
Sorry?
Two item need two times the database.
He will not do it if he's doing 2 times. I will be. It's confusing. So if the data here is stored 3 times, you can tell me that it will do 3 times the same job, because it will calculate here, and it's duplication. effectively is what Hadoop's doing, but for another reason. For another reason. It will only take one result, the fastest one. Why? Because one server could go down. So people could say, that's crazy. Why is doing 3 times, 10 times the same calculation because we have 10 copies? Yet there is one reason. Just imagine there is server going down during the processing. We need to have some concurrence and take the best one. The first who is processing the result, he take this one. But it will not take 3 times the same result. It will take just one result. So why is not scalable?
You can still map it out every single piece of data.
Yes. So the problem with MapReduce is that is need to reduce at the end. So if you have a big server, like 10,000 servers, if you want to have a query that it takes different data everywhere, you still need to collect all this data, and that need time. And so there is a timing on the server. More big server you have, and more MapReduce will be bad, because you need to collect all the results at the end. So it's not a problem if you have a big treatment to do, if you have a strong processing to do. If you take like 10 hours to process, it's not a problem. MapReduce works very well, it's good. But if you want to have something quick, just give it. Even for a small question, for a small query, you need at the end to collect the thing. So there is a time that is not, you can't deal with. You have to do this reduce bit. So that's why MapReduce now, no one is using it, because there is an alternative of MapReduce now. It's called James.
I didn't want to reply.
You don't want to reply?
Well,
That means you know the answer.
I even know it, or I'm hiding.
So the alternative of MapReduce is?
Also, you mentioned it earlier, Spark.
Yes, it's Spark, thank you. So Spark is another way to process, and why it's different than MapReduce is that it's doing that everything in memory. So you need a lot of RAM in the server, you're putting everything in memory, and that's faster. That means a lot of memory, but this is the way to avoid MapReduce function.
Just thinking that pizzas are here.
Yes, but I want to finish.
That's
very
fine, that's
important.
fine.
So the founder of Hadoop is Doug Cutting, and it's him, not this man. And it was great. I met him twice in my life, and this is a picture. I'm not a good photographer, as you can. I met him in Paris 2015. But if you see his Wikipedia page, he's very young, and I was so surprised. So yeah, he's quite well. He's very, very nice man. If you want to have a good chat with him, you just talk about cycles. He's a cycler. Just want to talk about cycles. Don't want to talk about techniques. But this man is one of the founder of Hadoop, the man who did the coding of Hadoop. So I think I finished after that. No? Oh no, I have a lot of things to say. Anyway, I will finish this one. We can go to the pizza. So. Cudera, Mapper, and Autonomous is a tree distribution of Hadoop. This is the 3 main distributor of Hadoop. Hadoop is open source for information. You can find it, it's free. You can take it and do it by yourself. It's quite complicated, as you can imagine. So there is some companies who embed Hadoop easily, and you can use easily. So they have even the servers already set up for you with Hadoop there. This is the 3 companies. So what's the difference on the 3 companies? Autonomous is the main one who is very open source. We don't want to do some, just think open source, that's it, roughly. Cloudera is the company who is the most active in the open source layer, so they actively create new things. We found what they have created after the pizzas. But what is very interesting is that every time they do something very interesting, they put that again in the open source community. So you can find it, not all, because they need to get some money, but most of the tool, they are after that in open source. And Mapper is the company who has changed a little bit the spirit of Hadoop. So they've been like the master. They don't have any master. So they changed completely the code of Hadoop, and now it's private code, so it's not open source at all. And they sell their cluster, and they say, our cluster is the best, is blah, blah, blah. Anyway, so there is a bit competition between the three major company who distribute Hadoop. So you can go to their website, you can download their a server complete, and even if it's not the spirit of Hadoop to have one server, because you need to have a cluster, but you can still play with Hadoop with one server. Yeah, let's stop here and let's go to the pizza and get back. Happy with that? Or you want to continue?
You can continue, me and Laura, we're going to
Yeah.
go on.
No, let's go for the pizza.
Okay, let's go for the pizza, guys.
Non, c'est vidéo. T'as dit ça? Non, non. Bon, comme il y a les gens qui passent des minutes. Pas grave.
Where is John? He said he's doing big data. I want to ask him.
That's what we got. Big
You are leaving?
No, I'm just thinking
Oh,
about
good. Good, good.
Yeah, to do that. You being the cameraman.
Yeah.
So I'm running into that. Or should we get back to pizza?
You going to upload all of the video footage? Or is that personal? We're going to keep it to the film?
That's what we used to.
Yeah, exactly. You're going to put it on YouTube? Big plan.
Yeah? Please, let's go.
send out the
I'll let you know then. See what roles we've got.
specific
Yeah. Great.
Thank you.
Right?
Yes.
This is more exciting than the Copla.
Sorry?
It's more exciting than the Copla.
Core platform.
We are working Copla.
Well, PMO.
No, PMO.
I'm PMO, but more closely with core platform.
So you see, it's more exciting than the Copla.
Yeah.
Yeah.
Get the head around it. I think we're misusing it. That's why it's good to. We have these conversations in our sprint reviews. We say, why are we putting this in Cassandra? Developers wants to keep Cassandra because it's easy. We want to look at the data afterwards, and I'm like, we have to look at it. It's not difficult because you can't really move data how you want to. It's how they create it. We always have these.
I will have a little bit talk about Cassandra. Yeah. Interesting.
Which distribution first is today?
Okay. Could we continue? Okay, so the first part I didn't see too much exciting, guys. So now we have got the pizza. We've got more energy, so I want you to be more active. Please ask questions. Like I heard in the break that some people didn't see very well the boards. I can move it. They have some wheels, so if you don't tell me that you don't see anything, I can't imagine. So it's the same as in your brain. If you have questions, if you have there's something it makes no sense for you, just ask. Is this moment is for you? So we're only in the what is Hadoop. We need to continue. Any questions for the first part? No, I think it's clear.
And the cluster, is that all in one geolocation or?
No, it could be split. It could be So there is a techniques about. That's a very good question actually.
Just from point of resilience.
Yeah. So there's different techniques in terms of there is some people who are doing the cluster in premise, and what they do is they separate the cluster in different racks in terms of with different power cables. So if something is going down, the other server is still working.
Yeah.
There is different techniques if you are putting that in the cloud, put that in different geolocalization. So if one is going down, still one is going up. There is different techniques to make sure that your cluster is Super. No, you can use any type of servers anywhere in the world. Main component of type of usage. I will try to go fast here because we need to do some more work on the NoSQL. But anyway, I will go fast here. But there is some keywords very interesting. I will go back in the NoSQL part. So in terms of data storage, we talk about HDFS, Hadoop data file system. There is in data storage in component Hadoop, there is what we call also HBase. So HBase is a NoSQL database. I will go through NoSQL in the presentation, so I don't spend too much time here. Kudu is the new storage. I will talk about this later also. I have some slides specific for Kudu. I don't take too much time. Parquet is very interesting. So, remember the storage on HDFS is storing the data. So there is different type of how to store the data. Could be JSON, could be different format. Parquet is one of the formats that is used mostly in the analytics world. I will try to explain that after that. But again, columnar, it means it's not anymore a classical database. It's not a rational database. Rational database, I put that every database you know in the world, SQL Server, Oracle, even Teradata, I will put that there. Anyway, Parquet is also going to the NoSQL area. I will have some slides for the NoSQL. I will try to explain that. So for the data integration, there is different. So get data in HDFS, you need to come from somewhere. You need to bring the data in HDFS. So that's called data integration. There is different type to integrate data. So there is Flume. Flume is the first tool that we can get data. It's more file data into Hadoop. And there is another way is called Scoop, but Scoop is more for a database. Like, for instance, you have a MySQL database, or Postgres database, or SQL Server, or Oracle. How we can put the data to Hadoop is by using Scoop. And Scoop is part of the Hadoop environment. And there is different also connectors to Hadoop. Processing MapReduce, Spark is the new generation of processing. And also now Spark is integrated a bit about machine learning. Not that much. The framework of machine learning of Spark is very, for me, is still not very mature. It's going better and better. But that's the new trend coming. So Hive, which is very interesting. So Hive, it was the first data warehouse in the Hadoop ecosystem. So this is something very interesting, is where they create another rational database in top of Hadoop, roughly. And Impala is using Hive beta store, but with massive processing parallel, which means using all the processing in the cluster, and they put that in memory, and is for the scalability and is very fast. Anyway, I will go to this Impala just when we're talking about NoSQL. Security is part also for the Hadoop cluster that's needed. So for instance, Kerberos and AD notification. This is what we've got here, for instance. We have an AD notification in top of Hadoop. There's different way also Sentry, etc. There is the way to encrypt the data. And there is also a data management tool that's possible. So Apache Atlas is the open source to manage the data and to see what's happened. But Cloudera Navigator, for instance, is still the property of Cloudera. They didn't release yet in the open source, so it's in money. But it's for me, is the best one in the Hadoop ecosystem. Query Navigator has a lot of features, and you can, after that, manage the data more easily across your cluster, which is quite very interesting, but it needs money. Okay, so just this slide after that, we can go to the NoSQL. So this is what's happened to Hadoop in the last 10 years. And this is what I want to tell you about, the fact that this the big data area, and this is the way when we try to process the data, etc., is going very, very, very fast, and it's changing every year. When I say every year is every month, every 2 months. So you see in 2006, it's starting with the core, what is called the core Hadoop, is the HDFS MapReduce. After that, it's going very fast, and they add more components. So I just mentioned HBase, for instance. So there is here Solar. So Solar, for instance, is the first, so there is different way to access to the unstructured data. So you have basically HDFS to store the data, but there is another way that you probably know is to index the data to get more speediness in terms of the search. And Solar is the first one in the open source. Pig is only an interface and is coding in top of MapReduce. So just to let you know, the core Hadoop has been coded in Java. So the first version, if you want to access to Hadoop, you need to code in Java. So Pig is the first interface where we can code in Pig, but it's more very user-friendly. You don't need coding in Java. The question is, why they code in Pig? They call it Pig, okay, because you have a lot of name of animals probably, but why Pig? They call it Pig because the code that the tool generated is very ugly. The Java that's generated is not nice. So that's why they call it Pig. it's true. So Mammut is the first machine learning platform on top of Hadoop, but honestly, don't use it. No one uses it because it's not nice. Anyway. So we talk about Scoop. Scoop is data gathering from a Russian database. So it's very evolving. So Flume, Big Top, it was very good initiative in the beginning. I don't know where they are now. I think no one uses it. But Big Top is the way that, because they saw a lot of components coming in Hadoop ecosystem, and they want to do something to understand all the components and get in one place. Kafka starting in 2012, which is very interesting. Kafka that we are using here heavily. Kafka is the way to, is better than Flume, is to collect data in real time. So let's imagine you have an application that is generating data in real time, and you want to put that in Hadoop in your cluster in real time and have the data in real time. You can set up a Kafka to is data collections, and you can is like a stream and get the data in real time. Obviously Impala, and Impala you can see there is drill and tez. Drill and tez is the so this is where you see the benefits or the inconvenience to having 3 companies with distributing Hadoop. So Impala, it was created by Cloudera, Drill by Mapper, I think, and Tez by Hortonworks. Yeah, Tez, Hortonworks, Drill, Mapper, and Impala, Cloudera. And at the end, they all created their own product. Is a only massive processing parallel. They're doing quite the same job. I would say quite, because I know that Hortonworks said, no, Drill is better. Honestly, yes, it is true, but Impala is doing quite a very good job. You don't need to go more better than that. Anyway, but the key thing is we have 3 different ways to do a NoSQL oriented column, which is quite nice for the analytics. And that's the whole 3 is on the open source Apache, and you can use it. So that's it for me. I need to go fast anyway. And the last one major change here is Kudu. And I have some slides for it to explain what is the major change, which is for us who is doing data analytics is quite very interesting. I will explain why. So that's it for me. And I'm pretty sure we will continue the next years. Okay, NoSQL. Let's talk about NoSQL because it's very important. For me, NoSQL has the same impact as when we introduced the databases in 1970. It's the new big change. What it is. I lost you again? So that honestly is a hard question. Why? Because there is the word SQL in there. SQL is a language. There is nothing about language behind. So there is a cartoon here. So you young folks are always against everything. Is there anything you are for? Yes, NoSQL. No one smile. It's great. It's a good joke. So it's honestly it's a bad joke because NO is there is no negation. So it's not NoSQL. NO is an acronym. It means not only SQL. And behind that is this is a new type of databases. It's not anything about language. It's a new type of databases and say you can query these databases, but not only with SQL. It's not a no, it's a not only, it's an acronym. That's why the joke is bad. There's nothing about against. NoSQL is not against SQL. And what is confusing is last week I did a conference about another subject, but anyway, and there is someone from Telefonica. This is his slide. He explained his Hadoop cluster, the architecture, etc. And he put that here, NoSQL, which is not that definition of NoSQL is not NoSQL, is not only SQL. So that's not very good to explain. Anyway, so you can see his slide, HBase, Hive, Peak, blah, blah, blah. But it's not definition of NoSQL. NoSQL is not only SQL. And we try to explain that. So NoSQL, there is a very good website here is listing all the NoSQL database. So after slide, he said that we have now in the world more than 255 more than 255 databases who are NoSQL. So it's huge. And everyone is creating his own view, everything. Anyway, there is another one. So what's the problem of that? So this trend is coming from the web, from the digital. And they don't find, the problem is more about when you are creating the databases, like MySQL, if people know that, or Postgres, or SQL Server, Oracle, you need to create your structured. So it's very structured. You need to have your tables, you have your columns, etc. It's not very helpful because you want to move a lot of things, you want to change sometimes, and if you want to store something, you need to be very sure in the beginning. Otherwise, you need to extend your table and change everything. So what happened to the data existing? A new column is embarrassing. So what we put by default for the old rows we've got is not that helpful. That's coming no rational. No relational. It's not relational. We don't want any more these kind of relations between tables, etc. Every data is storing by his own thing. Distributed?
Sorry, does that mean like no primary keys and no relations at all?
Yes. Yes. But, you know, primary key is something that we're introducing by relational databases to make sure that the data is consistent. The key thing is you can program by in your software that you can't enable the same data by a base on the key. You can do that. You can't just put this complexity in the database. You can do it in your software.
I thought I had a look at MongoDB some years ago now, so I might have changed that. But effectively, you're storing stuff in JSON, but it does have a criteria. You've got to put an ID on your JSON records.
Yeah, you have an ID. You have an ID for each. So MongoDB is one type of NoSQL. MongoDB is the NoSQL-oriented document. So the thing is, for people who are storing documents, or doing application for documents, is fantastic because you can store one document is one type thing. We don't need to structure the document. It's a document. But every document has an ID. The key point of having a key, the concept of key in relational databases is for the same document, for instance, if you have the same title, the same subtitle, I want a key for that. So I can't have two documents who has titles. This kind of that's not thing. Yes, every document in MongoDB has an ID. Yeah. The problem in MongoDB, for instance, that's why it's very not useful in analytics, is how you cross two documents.
Well, it does have indexing and stuff like that, doesn't it?
Yeah. So if you have, for instance, if you put all your books in a library in MongoDB, and you want to have, okay, give me how many books from this author. Ooh. Difficult. Very difficult. So you need to go to every type of books and have the name of the authors and get the number go down. So it's ugly because we can't cross the documents in the MongoDB. Distributed, that's very good. That means most of the NoSQL working in a cluster, again. Open source. Most of the NoSQL is open source. And horizontal scalable. That means you can add more data, it's okay, it will scale. So the origin of this is coming from the web. And so most of them are schema free, so that's what we said. There's no need to structure the thing. Easy replication support, simple API, and this is something very interesting. Eventually consistent, not ACID. And I will go to the details of what it means, ACID and base. Can handle huge data amounts, and this is something we need in the big data sphere. We don't want any more database that struggle when they get a terabyte or petabyte. So, what is ACID? So I give the definition of ACID just in the next slide. So, I will go to data and it's more on NoSQL. Why is it necessary? Let's get back to the. Everyone has a concept of databases, like SQL Server, like MySQL, etc. So the main change, what's happened in 1970, is to move from the file system. So let's imagine we were in 1970, and all the data has been, if you have a computer, is stored in files. As you know, we still have that in companies. If someone working in Excel, someone else can't work in Excel. He can work in Excel, but just on the read only. He can't modify at the same time. And that's the problem. Why? Whilst two people can go and modify the document and have a good state of the document and state is stable. So the main, when someone modify it, the other one who is working on it is view also the change. So that's the concept of databases. That's why databases is coming a long time ago to change that, to change this concept of this kind of problem. So ACID is come from there. So atomicity, the transaction is fully completed successfully and will return in initial states. That means when you are modifying data, doing something in data, the database will take over. If it's a bad query, we reject it. The state of the database will not be disturbed, it's still running. Consistency. The database is steady state before and after transaction. So that means that's a very important thing to understand. When you create a transaction like an update or a delete in the database, if the transaction has been accepted in the database, it will change the state, and that's consistent. And everyone who is running after that, it will have the state. So we will see that has been deleted or has been updated. That's called consistent. And that's the main thing that NoSQL didn't anymore support. You say, wow, what's happened here? That means it's bad then. I will explain why in a couple of slides. Isolation, that means the transaction is completely independent of the others, so there is no problem, there is no there is a queue to manage the conflict. And durability, on transaction completed successfully, the change database is done and is for all if it has been successfully changed. So this concept is a long time ago, is a concept of databases. Why we love databases? Because of that. However, now databases can't handle the big data. So how are we good at how they can't handle unstructured data? So that's why NoSQL is coming. And NoSQL is coming. NoSQL is not magic. It's not something that we need. There is something we change, and it's not like the magic word or everything will be fantastic. It's not that. We need to review this ACID concept and maybe change a little bit and have another view. So, if I go more deeper, there is someone who said Eric Brewer with a CAP theorem. This is his CAP theorem. He said that we can't, databases, in any kind of databases, it can't do three things in the same time. It can't be consistent, it can't be available, and it can't handle a partition in the same time. That's not possible. This is the CAP theorem, and I'm laughing here because I remember a chat last year with DataStax, who is the company who is managing Cassandra, said, no, that's not anymore true. We, Cassandra, we handle the three things. Go away. That's not possible. We need to be careful about that. We need to understand what we should do with the databases. Anyway, so this is the cat theorem of Eric Brewer. You can see it. So consistency, availability is where you are in Russian databases. Every Russian database is there. However, this is the NoSQL area. So MongoDB is here. So MongoDB is more consistency and partition, nothing about availability. And we have HBase, and we have Cassandra over there. So most of the NoSQL didn't handle the consistency. That's not possible with the partition, and I will explain why. So let's go to the base definition. I will give you an example. Is here. So this example is very interesting for NoSQL. Let's imagine you are a web tool, a web very famous, like Facebook or like LinkedIn. Have you noticed that in LinkedIn or in Facebook, when you post something, if you refresh your page, you don't see your post? You need to wait a little bit time, 4 seconds, 5 seconds, refresh, and you see your post. Sometimes when you comment a post, you refresh your page, you go to the thing, and you don't see a comment. You can see sometimes in a post you have 3 same comments because he's starting again to do things. That's the problem of consistency. Why? Because this is exactly what we talked just before the pizzas. I will try to push this one. So, this is the problem of consistency, really. And it's something we need to know. And this is something a lot of websites didn't handle because we only have this technology and it's not an issue, if you want. So, do you remember we have a cluster and we store the data in HDFS, and we have a NoSQL on top of that. Most of them could be Cassandra, could be whatever. The thing is, the data is somewhere in the cluster. So, and there is a program or a user who modifies something, create a new post or create a comment, etc. You will access to a cluster and it will add a new data somewhere. And the cluster, he saw a new data, it has to duplicate the data. We say before the pizza, by default 3 times. That takes a little bit of time. So let's imagine you have someone, you, or someone else, is querying the cluster in the same time. This data is replicated. The new data is coming. So you can, the master, if you go and ask a new question, he can use a server that's not busy to give you the answer. And the data will probably not be duplicated, or probably take the old data that is not changing by the first request. And this lap of time is increasing depending on the size of the cluster. In a database, it's not possible. You go into the Russian database, it's not possible. You go into the database, you change the database. If someone is coming just a fraction of a second just after, you get the new thing. But in a cluster, it's not possible. Because of the nature of the fact that we partition the data. So that's not a problem for Facebook, it's not a problem for LinkedIn, it's not a problem for all these social media. But if you need an application that is neat very exactly at the fraction of time, exactly the change of the data, probably NoSQL is not you. It's not what you need. But honestly, it's very rare to see this kind of thing.
Is that a NoSQL thing or a Hadoop thing? Is that a NoSQL thing or a Hadoop thing?
The same, because most of the NoSQL will use in the background Hadoop. Most of them. And even NoSQL is partitioned. Like if you're using MongoDB, which is not Hadoop, it's NoSQL. Most of the case, MongoDB will tell you that it's better if you have a cluster. So you need to have different things. So it's the same because MongoDB will be in different. You can't ask to have availability for everything, and after that have the consistency. And it's not possible. But don't be scared, it's not a problem. LinkedIn is doing that, Facebook is doing that. It's just a fraction of seconds. I did some tests with LinkedIn, it's more like 4 seconds. But 4 seconds, is it a problem? Yeah. Is it a problem that there is some people who didn't see the comment and add another comment, and after that he refreshed, oh, I saw 2 comments now. Is it a problem? It's funny? But that's the problem behind, because we are in the big data space. And this is the problem of consistency. So next time if you see 2 comments in the link, you say, hey, consistency. NoSQL is not consistent. No? Okay. Having fun? Okay, let's get back to the base then, because it's very, very important. So NoSQL, what we said, NoSQL is not anymore ACID, it's base. The base is what? It's basically available. So the system is remain available, even if there is a failure node. So if there is a node, that's why there is some people using MongoDB in single node, which is bad, because NoSQL is great. If the node is delayed, is switch off, that's not the problem. It's basically available. Substate, very low consistency rules. So that's the substates. So there is no rules on the data. So that's why a lot of people, a lot of developers like to use Cassandra, put everything. There is no checks, nothing, is getting everything. So you can push what you want. It's very flexible, but after that it's very dirty if you want to analyze the data. Eventually consistent. So this is eventually consistent. It depends on your luck. But at the end, it remains consistent. So it's not the fact that it don't want to be consistent. It will become consistent, but after a certain period of time. When it says certain period of time, it's not hours. It's just seconds. I see in my life once in data analytics, once the problem of consistency. So we just finished the processing. Someone has running a report, get the figures, and me are running quite a couple of seconds just after, and I get another answer, which is quite annoying. Because the processing has finished, so we should have the same answer. No, it's eventually consistent. It's very rare to see it. But if you have a small cluster, you will never see a problem. The problem is more when you have a big cluster. That makes sense? Mm-hmm. But it's very important to talk about that because everyone talking about NoSQL is magic, is fun, is great, blah blah blah. No, there is some limitation. We need to know that. It's not a huge impact. However, we didn't find yet another way to handle the big data anyway. So it's still very good. So this is an example of what I exactly said in the whiteboard. So the data is replicated in the node M and N, and etc. There is a writing. It happens sometimes, etc. So this is the problem of the consistency. So different type of NoSQL. So there is more than 225 databases called NoSQL in the world. So every year, I remember I changed the number. Every year it has changed, and now this website stopped to count. You just say over 225, and that's it. It's now 2 years now. It never updates that. It's just stopped to count. It's crazy. So there is different type of NoSQL. I want to stay a little bit here because it's very interesting. So the first one is the key value. So the key value is very interesting. Is database like HBase I mentioned previously, or Cassandra. Just to let you know a little bit story about HBase and Cassandra. So you know which company are starting to create Cassandra, to the project Cassandra. Which company?
Yes.
Which? Who said?
Yes.
Yes.
Facebook.
Yeah. So it was Facebook who started Cassandra. They wanted to create a database that has a key value. It's more about your friends. So you have friends. You is the key, and friends is the value. They found a way to say, okay, it will be very fast if you store the data like that, and if we query, if you want to know the friends of your friends of your friends of your friends of your friends, it will be very efficient, because after that I can use the key every time. It will be very fast. If you ask Facebook, they don't use Cassandra, they use HBase. So every time when I go data stacks, they say, well, very, said, yeah, but you're using Cassandra. You know who is creating Cassandra? Say, yeah, it was Facebook, but Facebook didn't use Cassandra, they used HBase. For what? That's great, then very annoying. You can ask them, and they have their own version of the story. HBase is the same concept, is key value. And HBase is top of Hadoop, so it's based on the Hadoop ecosystem. And it has the same thing. If you want to store data that has a clear key performance on key value, it's very good for that. Document oriented is another one. So I said key value, HBase, Cassandra. Another one is documented. So if you have an application when you want to store documents, like web page, comments, whatever, books, blah, blah. MongoDB is one of the NoSQL oriented documents. There's another one very famous, is Couchbase. Is another NoSQL oriented document. So this is another way to store documents in NoSQL, etc., in a cluster. The one I like is column oriented. Why? Column oriented. So column oriented, Parquet is the format of column oriented. And on top of that, it's all the NoSQL that's using this kind of technology is Impala. we said drill, tears. So why I like this column-oriented NoSQL? Any clue?
For analysis.
Yes, but why? Why
Because
is
when you analyze, you only have to focus on the column. Yeah, when you do a OLAP table for a query, you need to give us one row.
make sense for everyone? No? No. So basically, when we see the data, everyone, if you are using databases, you know you are thinking like an Excel spreadsheet. You have columns and you have rows. So that's a basic way to store data. A database-oriented column is flipping the thing, is storing by column. And it will store the data only once. So if you have, like for instance, in your rows, the same customer, or the same ID of a customer, it will, for the column, said like, we say address. If you have different address for a customer, it will create only one address, not multiple in the rows. We take address, is belong to this ID, but is one address. So we're gaining in terms of storage. We're gaining because the packet format is also a binary format. And the storage is better for that because we are in the analytics doing a lot of search, a lot of workloads, a lot of things. And it's amazing how much is very fast in terms of analytics. And that's why it's not only SQL, because you can do SQL on top of that. It's not NoSQL. We don't want any more SQL. No, we are doing SQL on top of that. The last one is, this is the 4 major type. Last one is oriented graph. The major one is Neo4j. Have you heard about it? I can't say anything about this. Neo4j is one of the major graph database. People are using graph database is Neo4j. So graph database is when you want to store relationships on people, and it's very efficient. You don't need to store tables, you just store links and etc. However, in terms of analytics, it's horrible. If you want to do some analytics on top of that, it takes a lot of times. It's not designed for that. So that's why different NoSQL database, it depends of what you want to do really. If you want to do some, like me, analytics and queries on top of huge databases, NoSQL oriented column is the best. I will show you an example. I don't know if it's the next slide. Yes. So this is an example on. So this is a table we got in our cluster, and this is the same table in SQL Server. And this is the number of rows. Stop it. This is the number of rows we got in the table. So it's 956 million rows. Quite good size. And if you just say select count on the table, this is, by the way, who. So it's a Cloudera distribution of Hadoop. When I run a SQL, like SQL count me the number of rows we got in the table, it take me, how long it take? 1 second, 1 second and a half. In SQL Server, I stopped the video and it take 1 minute, 30 seconds without any optimization in the both sides. That's what we need, that's what we want. We want a scalable environment that we can handle a lot of data and we can be fast in the analytics. And there is no optimization, nothing has been done. The same table put in, this is Impala in packet format, NoSQL oriented column, and this is a rational databases. I did no transformation. So when you put a table, the same table, in NoSQL oriented column, it will transform the data. It will put that in this format. I didn't make any more effort. So that enables a lot of things. We can analyze a lot of data. So we are not scared when we have millions, billions of rows. It's not a problem at all. And even if it's going to be a problem, if the processing some queries taking because we join different tables, blah, 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 there's a way to optimize it. But even if it's a problem, what do we do?
Is it called sharding? Basically, growing your shitty cluster.
We have a cluster. So you have a problem, we add more servers. That's it. Make sense? I think I lost you, everyone. It's time to sleep. So that's a typical example where Hadoop and all these NoSQL benefits on a cluster is very interesting. So I didn't say that all the NoSQL is not important, is not good for what they do. It depends on the subject. For instance, HBase or Cassandra are very good if you want to do an application behind, if you want to store data, if you want to have a customer who want to write something and store the data. That's what it's for. In my job, I have no application with a customer. Me, I'm collecting the data, I'm analyzing the data. So my key thing is to enable any kind of analytics, any kind of queries, and I want to be able to do that and not be struggle and run a query and need to go to coffee, because if I need to create 10 queries, I will have 10 coffee a day, and after that I will be very, yeah, and I need to sleep in the night. But that's honestly, it's a way to be fast and to be more efficient. So Kudu, this is the new thing coming. So we are now talking about something very, very new. Has just released the version 1. I think it was 6 months ago, or maybe earlier than that. So the problem, I need the whiteboard again because there is another problem. So we talk about the benefits, we talk about the constraints of Hadoop, etc., etc. There is another problem, a big problem, and this is where Kudu is coming. So in terms of Hadoop and HDFS, the problem we've got, and it has not been a problem even without Kudu. I always found a way to not be concerned about this problem. In HDFS, so when we store the data, so why I'm talking about an HDFS? Because every type of data is stored in HDFS, even the NoSQL in Hadoop. In HDFS, when we got some data, there is no possibility to update the data. There is no way to just delete a small part of the data. So let's get back to SQL Server, let's get back to a relational database. If you have a table, you can delete one row. You can update one cell. In Hadoop, in HDFS, sorry, I wish to say, in HDFS, it's not possible. So the data is here. If you want to change it, you need to remove it completely and take the row. Yeah. That's Kudu is coming from. Yeah, honestly, I didn't see. We have some constraints a long time ago. We have some jobs in the big storage called Teradata, which, if they ask Teradata, now has been bought. Anyway, Teradata, no, I'm working with not Teradata and Metadata. The two, the data is IBM. If we are talking about big data, we say all storage is big data. But when we ask if your storage can handle non-structured data, they will say no. So how can it be big data? Because for them, big data is volume. So I was working in Teradata and Metadata, and we have some ETL process that is doing updates. When I moved to Hadoop, we have this issue about we can't update the data. However, if you understand how it works at update, we can handle that easily without an update. Anyway, so I never seen, it was a constraint, but I never seen the way to find a solution without delete or update. However, now Kudu has another storage. So Kudu is another storage in top of HDFS, which handle this kind of problem. So we can update the data, we can delete a single thing, and also it's very fast. So this is the slides coming from, because Kudu has been developed by Cloudera again, but now it's open source. So this is a way how they present Kudu. So Kudu is a good between HBase and Parquet format, which is NoSQL or the column. So it's a good alternative between them. So it's quite good in the online and random access. So this is good for HBase. But in terms of analytics, is quite sometimes better than Parquet. So this is how we can see the performance. So for instance, if you are loading some data, you can see the time and how much is performant. So it's still not performant as Parquet. So this is a type of query after that. So this is a const star, is still quite good. The const star where Kudu is better. And when you do a single row lookup, this is where the key value is better. When you do a lookup on the data, HBase is better. So why is say Phoenix here? Phoenix is an open source in top of HBase. So this is a way to query HBase. It's called a Phoenix. And this is Phoenix is also SQL, so you can do SQL on top of HBase if you want. And this is called Phoenix. So Phoenix is HBase roughly, the green is Kudu, and the yellow is Parquet. So you see here where the key value is very interesting with HBase. If you need to have, I want a single value for one person, for one key, obviously HBase is better than anything else. So that's why Kudu is quite very good performance. So even in a const star, is quite close to the NoSQL Oracle column. So this is the slide coming from the test coming from Cloudera with a 10 nodes cluster, which is not a very big cluster. That makes sense, or I lost you completely? It's too much? So we are starting to use Kudu. So there is some, it's early version, so it's only 1.1 version. there is some limitation, but it's quite very interesting because it's enable all the things we used to do with rational database like delete, update, etc. And the performance is not that far from Impala and the packet format. Make sense? So, so this is quite an architecture of Hadoop cluster. So we have, as we said, single point of failure of the master. So we have two masters, and all of them we're calling walkers. They are all walking, and they are all storing data, obviously. So there is the H servers. This is where we access to Hadoop. So for instance, the screen you see about the who is from the H server. Cloudera manager is the server who is managing the Cloudera servers, and we have the Active Directory to access to enable the security access. And there is every time, by default, this is very funny, by default, the meta store from Hadoop is Postgres database. So it's a rational database, by default. We can change it if you want. So there is also something very confusing in. So I said in the beginning, Google didn't have any backup, and I saw some faces. What is doing? Google has done a backup. So probably understand why now. Even that, I saw some companies doing some funny things also with Hadoop. So you have in your company probably different environments because you need to test. And you have a test environment, and you have a development environment, you have the pre-live environment, and you have a live environment. Some companies have 6 environments. It's difficult to manage after that. It's difficult to know where is the data, etc. And there is some company I saw when they set up the cluster Hadoop. They have physical different cluster for each environment. What's the point?
Development environment, you'd have anonymized data, whereas in live it's real customer data, so you wouldn't want to go anywhere near it.
Yeah, but why we can't split that? We have a resource management in that.
Yeah, keep separate.
Why? And this is a way also to say, why keep it separate? People I think about, I remember some times ago, we need to keep it separate because if it's falling down, this is a server, this is physical thing. If it's going down, we don't want the live going down. But we have the resource management. So we can, if it's a developer, you can have access to the dev and access to the, if you want to access to read-only on live, you can do it because you have access to it. And after that, is Hadoop who is managing that. Physically, we can split that. And this is what we've done. So for developers, he has access to the development Hadoop. This is what existing in some companies. What we've done is that we have one cluster Hadoop. And by using the resource management, we know exactly how to split the data inside the cluster. So we have inside the cluster some layer, is a more logical layer. This is the dev environment, and this is the test environment, and this is the live environment. Depends who you are in Active Directory. You can write on dev, if you are an analyst, you can only read in live. Anyway, anyone only read in live. It's only the project account who can write when there is some step on deployment. But there is a question in every time in the old age of data warehouse. The problem is when you have different environments, how we can test the data. Because every time in the test environment, there is not a lot of cases. We need to bring the data, we need to bring some cases, it's a long journey to get the right data, etc. And even that, when you do the ETL processing, we don't have the same performance because it's not the same data. In live, it's different. And you try to create a program, you try to create all the processing, you are happy, it's taking 5 minutes. You go to live, it takes 10 hours. Oh yeah, because there is more data. Oh, there is some cases that I never seen, and there is a bug. Oh, these cases I never have in my test data. I can't do it.
So in that setup, is the data in the test environment always changing based on what's happening in production?
So in the dev environment, you have access on read-only to the live data. So you can do your test on the live data and the right thing. So if you have the need to create a new table in the dev, a new data mart, you're creating based on the live data. So when we peer review the code and we want to move in the test, there is no integration, there is no new thing we discover because we already worked in the dev with the real data. So the performance will be there is no new use case about, oh, there's a new data. It happens because new data start coming, the project is live, blah, blah, blah. But in dev, we have all the cases we need to do a very good dev.
Let's say you put your test analyst hat on and you was testing in test environment.
Yeah.
And you've got a customer account or a record.
Yeah.
And you need for it to be controlled.
Yeah.
How can you be sure then that production has not changed that account or that record while you're trying to test it? Because you don't want it to change. Or you control the run your test or do whatever and then see what the output is.
Yeah.
See what I mean? With your test hat on.
Yeah.
And the tester, does it still work?
That's a good point. If you want to keep the data to make sure that you want to test the end-to-end thing, that's another way to copy a part of the data and make sure this is, if you want to test the end-to-end process. So copy the data and have your proper environment. Most of the time, we are more doing analysis in the data. So anyway, the data will change, the value will change. So we want, at the end, to have the more existing cases to test the scenario. It's not like when you want to test the software and have a different thing. But in that case, I can understand you need to freeze the data and not change it to make sure that your scenario is working.
Sometimes you just want, it's like a lab test, isn't it? Controlled environment to make sure that when you do your process, that nothing else has affected it. So, so some people scared about that and said, "Oh, that's."
I wouldn't go near that.
You know, everyone is scared probably because it's a new thing, etc. We, in the last 5 months, we never changed anything about the configuration we had.
Yeah.
Never. It's setup. It's good. If we need more performance, just add servers. The setup has never been modified. So
you're not scared about cross-fertilisation of information, or sort of accessing the wrong table and accessing customers' real data?
That's set up in the security layer.
Yeah, of course.
Not.
So you don't ever have any cock-ups when you're modifying configuration.
Configuration of
the partitioning of the information.
No, because you have in the live data, it's only read-only. You can't modify the partition in the live data.
Okay.
You can't. The only icon to create and modify things in the live data is the project itself. So that needs a different layer in review, in the processing. So I will show you how it works.
Yeah, okay.
With deployment process. So deployment process, for instance, so this is only for the dev environment. So the developer, the first thing is pushing his code in Stash, which is now Bitbucket. And so everything after that is quite automatic. So we are using Jenkins to manage the jobs. And if Jenkins thinks that the code is okay, is alerting the branch again. So all of this is running, all the tests is running by another account. It's not the account of developer. And all the green is completely automatic. So it's not the developer who has access. He has access to the live in read-only, but you don't have access to write and modify the data. In the live, it's getting more complicated because we are using rundeck to run. This is rundeck already, everything in live. And he is past the test version, the rundeck take over, and it's the only one who using the live. And all of this step before, so the branch here on the dev, so there is a way, so there is a methodology is about make sure that the pool, so no one has access to the master in Bitbucket, and everyone is working in the branch, and when, so there is only way to merge the branch to the master if we have set up the peer review. So there is someone else who need to do the peer review of the code and check if everything is compliant. So there is a way to also to make sure that we are not pushing the code that is quite crazy. Anyway, there is almost minimum two responsible of the code. So that's it for me. That was the end. I think we get all the area, big data, Hadoop, NoSQL, and how we deploy the codes in Hadoop. Any questions? You get to get the right place. You were sitting and sleeping, and me, I'm thirsty. Any questions? Seriously, any?
We seem to the concept is similar to like other technologies, blockchain, probably heard of blockchain and RAID arrays. Do they link in or do they compete?
It's completely different. Completely different. So the thing of blockchain, they don't handle the big data problem. Blockchain is more about to handle the trust and get more people having the same data and have a federate view of things. There is no someone central who have all the data and guide everything. So this is what they tackle blockchain. It's not the big data problem. But there is a very good, interesting subject about big data on top of blockchain. However, blockchain is more about, if you think about blockchain right now, most of the use case is more external to the company, not internal. However, there is quite some good use case internally. So it's more about everyone has the truth, and so it's not possible to change something because everyone has the right data. So let's imagine in the energy market, for instance, let's imagine if the data of the measures is stored to different peers. So everyone has the right data. It's not the government who store that. Everyone has the right thing. So if someone wants to change the location, move the house or change the meta, everyone will be updated and everyone will also say, okay, this one effectively live here, so we agree for this change, or we agree for this transaction. This kind of technology. So the first concept is the bank. So blockchain wanted to tackle this problem about having a central bank controlling everything. That was the use case. It's not the big data.
Okay, so they can complement each other, not?
They can definitely complement because it's not that huge right now, the size of the blockchains, public blockchains, I would say, not private blockchain. There is one country who is getting very, very fast in blockchain, which is very interesting to follow, is Estonia. I don't know if you have heard about this country. Obviously you know Estonia, but what they've done after they went away for the Russia, they changed everything in the government side. So everything public, everything government is in blockchain. So they set up the first blockchain. Some part is private blockchain. Like a policeman has an ID card. Every citizen has an ID, digital ID. And for instance, in Estonia, if you want to buy a house, it takes 3 days. Because everything is digitalized and everything is running in blockchain. So if a policeman wants to do a quote to you because you did something, he needs to identify himself. He needs to say what he's done. Everything is auditable. Not everything publicly auditable, but everything can be looked at. For instance, every minister, the government of Estonia, they have no paper. If you see them, they have all an iPad. Everything is public. Every meeting is public. And the president is a woman. President of Estonia said, now any country of Europe can come to us. No one can beat us. They have very good study about how they get efficiency, and I think it's the country who has the less people working in the government side, because everything is completely automatized. That's a very good. It's a very good subject. Not talk sometimes, but yes, the main topic of blockchain is more about trying to have federate trust rather than having a central control. But big data and blockchain. So if you take like the first version of blockchain, which is the Bitcoin, if you see the data behind, is not that huge. So we are not talking about teradata, we are talking about gigadata. So they didn't reach yet 300 giga. So it's very teeny. In terms of the problem we are just evoking about big data, it's not that huge. But if you combine all the blockchain in the world, yeah, maybe there is a big data problem to solve. Yeah.
So in sort of the context of versatility,
yeah.
when our dev teams start on something new project, new software deliverable, we have these conversations about whether this data should go in a relational database or whether we should fire up a NoSQL database.
Yeah.
And so I just wanted to understand, what's your thought process that you would go through in your head to try and sort of decide whether it is a relational database or a NoSQL store. I'm not convinced we always get it right.
But the first thing, the first thing to know is the size. We can't handle we can handle 1 terabyte in SQL Server. We can handle 1 terabyte, I think. But if we are talking about a small application that we know that it will not reach like 50 gigabytes, I don't see the problem to use a rational database. There's another thing about consistency. Do you need to have consistency in seconds to this application? The first thing is the change of the data. So I can understand why developers like Cassandra, because it's schema free. You can't, if the data is changing every time, you can't use rational prevalence because you need to change the structure, you need to change the schema of your database every time, which is quite annoying. So I will ask these kind of questions in every application, and after that, go for it. But even if you want to use Cassandra, if you have a huge aspect of analytics, Cassandra is not, it will not handle analytics. It's like HDFS, if you see the thing. If you do a constar in a thing, Cassandra is very not efficient. So that's the thing to consider.
So something like, so you know, we've got 1 million customers, and let's say they all had smart meters, and every 30 seconds we was getting a smart read. Would you classify that as big data, just out of interest?
One read every half an hour.
Every half an hour, sorry, yeah.
Every half an hour for every household is getting, every half an hour one read for every household. Yes, is getting to the big data sphere. But after that, it depends on what, we know that this data, but what we're doing behind that. Is it an application on top of that? Is it analyzing the data? So there is different way to see this kind of thing. So for me, analyzing this data, yes, I have my solution, and no one can challenge that. However, if you are building an application on top of that, like for instance, allowing people, customers, to see the thing, or change, or comment, etc., is another type of application, and that could be challenging. But let's talk about this.
Because we always have to challenge, and Shaz will know this quite well. We have a live problem, I'm trying to work out what's gone wrong. Trying to work with.
No, Shaz, no, Shaz is a Kudu fan now. No, he's okay. He's he wants to use Kudu. Any questions?
Just
yeah.
What you've sort of been talking about is in the concept of data analytics.
Yeah.
And this is your potentially your analytics solution.
Yeah.
And when you talk about live, so this isn't. I'm just trying to figure out. This isn't your kind of customer contact meter reads build type system as well. That feeds in to this type of system. Doesn't it? You've got another system that does all that.
Yeah. Yeah. So what we put, sorry, that's a good point. Sorry. So the Hadoop cluster we got is we call it data lake. So it's a data warehouse like. So we have the system in place, but my job is to analyze all this data. So we need to cross the data, we need to get fast, and we need to do some analytics of it. So we have also different projects about predictive analytics on top of that. So that's another topic. I have a talk. You were here in November?
I think that's what you just said. Sorry.
I said we have also predictive analytics on top of that. So we are not using Mahout in the Hadoop environment. We are using more R and Python. And I did a talk in November about data science, how we manage data science, and how we can be more efficient in terms of the methodology, and which machine learning model we are using, kind of thing. So I can rerun these meetups if it's needed, but it's not a subject like blockchain. It's not a subject. Any other questions? You have a question. You were concentrated all the meetup and.
I was concentrating on everything else. I've got no questions at the moment.
Okay. Thank you, Abid.
Anyway, keep contact anyway. So anyway, I'm a public person, so I have my LinkedIn profile. I'm a LinkedIn man. I like LinkedIn, even if people are commenting twice or 3 times a comment. So you can contact me by LinkedIn, and
we can keep contact and ask more questions after that.
Just before everyone does rush on, we do this every month. We try to get talks which people want to hear and people in, whether it's people like Abid or external speakers. So if anyone does have a topic, blockchain or something else, if they do want to have a talk or a discussion, we will try to get the right people in. Or maybe you guys want to come up here and present for half a session or a full session. Please get in touch, drop me a message on the Meetup site and we'll see what we can arrange. Before anyone does go, Laura has got a sheet that we take names for everyone that's attended for our records. Quite conscious that a lot of the internal staff have sort of walked in from their desks and not signed the sheet. If you could do that.